what I'm going to do here is go over a bunch of special scenarios where your ordinary combined rates equation, which is this, 1 over t equals 1 over a plus 1 over b, where this ordinary equation doesn't quite fit the problem that you're given for a variety of reasons. Maybe you have multiple workers that require more than just a and b. Maybe you have multiple jobs. Maybe you know the total time, but you don't know how long it would take Bob by himself. Or maybe one of the workers is working against the other one, like they're trying to dig a hole and one guy keeps filling it in. Or maybe we don't know how many extra workers we need to finish a project according to a time limit. So let's go over some of these, and I won't solve problems all the way through for some of these. We'll just give the basic idea of how you approach it. So let's say you have 4 workers. Okay, and we want to know how long it takes them to do a job. Well, you would just say 1 over t equals 1 over worker A time plus worker B time, and you keep on adding workers like adding fractions. Okay, so see, now I've got 4 workers, and we would have to solve this rational equation, again, by finding common denominators and then crossing out all the denominators and solving for the variable. If you had multiple jobs, okay, something like this might pop up. If you have one person who can, I don't know, let's say a carpenter has hired people to build sheds, and one person can build a shed in 8 hours, another person can build the job in 6 hours, and the carpenter decides he wants to give these workers of his a big project and have them build 5 sheds. Question is, how long is it going to take to build 5 sheds? Well, this is easy. All you do is you figure out how long it takes them to build 1 shed, and then you multiply it by 5. Okay, so in this example, I'll just go through this one. We would find common denominators for everything. My common denominator that I want is 48t. Okay, so that means 48 over 48t equals 6t over 48t plus 8t over 48t. If you don't see where I got those numbers, pause the video, go through the process of finding a crazy one, and convince yourself of what I just wrote. Now we're going to cross out all those common denominators. Okay, and then we have our equation up here, which is just, give me my pen, which is 48 equals 6 plus 8 is 14t. Okay, so that means t equals 48 over 14, which is 24 over 7. Okay, that's t. But if it's 5 jobs, then you have to say, well, the time required is 5t. So that's going to be 120 over 7. Okay, so that's how we do multiple jobs. You just multiply it by however many jobs there are. Now, if I want to find out how much time it takes one worker by themselves, it's just a rational equation. We put everything in our combined rates equation. Let's say we have a little information. Let's say the total equals 10 hours, and person A equals, I don't know, 8 hours. What is person's B time? So you just set up your equation the same way as you would before. 1 over t equals 1 over A plus 1 over B. And now you plug in the numbers. So that's 1 over 10 equals 1 over 8 plus 1 over B. And now you're looking for common denominators. And then once you find the common denominators, you're going to cross out all the denominators and solve the equation. Okay, so I'm not going to go through that one. You can use this example right here with the multiple jobs if you need a reminder of how to solve rational equations. But let's keep on going. Let's say we've got a working against problem. And I don't know, there's all sorts of ways you could imagine someone working against someone else. And this isn't just the case of someone being slow. This is the case of someone actually undoing work. So I'll use the example of a leaky pool. Let's say someone is trying to fill a pool with a hose. Okay, here's my pool, and I've got a hose going into the pool, and it's filling it up. But there's also a drain, right? And some water is leaking out of the pool. So the question is, how long does it take to fill up the pool, even given that it's a leaky pool? So we have to know the fill time. So let's say fill equals 10 hours. Let's keep these numbers simple. And empty, say the leak is fairly small, it would take 30 hours to empty the pool. How long is it going to take to fill this pool up with a leak in it? So what you do is you take your 1 over t plus 1 over, not plus, it's still the same equal sign. 1 over t equals 1 over a plus 1 over b, right? That's our combined rates equation. And now we plug in our numbers. So 1 over t equals, I'll use a for my fill time, 1 over 10. And because the emptying is the opposite action, right? It's counterproductive. It's going in the opposite direction from the normal work. I'm going to do 1 over negative 30. Okay, 1 over t equals 1 over 10 plus 1 over negative 30. It's negative work. And now you would go through and solve that problem, probably finding some, I think 30t is a common denominator, negative 30t. So we're going to say negative 30 over negative 30t equals negative 3t over negative 30t plus t over negative 30t. Okay, negative 30t was my common denominator. And now I cross everything out the way we've done before. And what's left? Well, we have negative 30 equals negative 3 plus 1. That makes negative 2t. So t equals 15 hours. So you see that leak is going to get in the way of filling up the pool. It won't fill up in 10 hours like we expect. That's how you do a negative work problem, or a working against problem. I don't know if there's a good name for those. And then last example, how many extra workers do we need? So this is a case where you say, I don't know, say we're moving somebody into their house and their van just arrived from out of state, and here we go, we got a big moving van here. Okay, and we got lots of people, and the question is, how long are we going to need to empty this van? And let's say the guy who just moved in is going to take 20 hours to do it by himself. He's a fast worker. He would do it in only 20 hours. And he wants to get this thing done today so he can return the van. So he hires a bunch of helpers. Okay. And he thought he was fast, but these guys are pros. They could each do it in 15 hours. And there's as many of them as he wants. So the question is, how many of them does he need to hire to finish the job in 5 hours? So the job needs to be done in 5 hours. How many workers should he hire? They're faster than he is, but he's still going to help. So the way we do this is we do 1 over t equals 1 over a plus, so a is this guy. Okay, this is a. And these guys over here, these are all b. They're all going to work at exactly the same rate, 1 over b. So 1 over b is 1 worker. 1 over b is 2 workers. 1 over 3 is 3. 1 over b is 3 workers. I don't know how many of them I need. Okay, so let's call this a question mark. How many of those workers do I have? Well, I can declare a variable called n. N is the number of workers I have. Okay, so let me write this equation this way. If I have 17 workers, it would look like this, where n equals 17, right? So now we solve this equation, and let's go ahead and try that. I need to finish this job in 5 hours, right? So 1 over 5 equals 1 over this first guy, let's call him Andy, plus n divided by b. b is how much time the professionals take. So now we can solve this equation. This isn't too bad. Let's see. This is going to be n equals 15 times 1 over 5 plus 1 over 20. That's just a rearrangement of what I did. Go ahead and use your basic algebra skills to do that one. You can see how I got those terms where they are. And I'm just going to pop these into a calculator here and see what this turns out to be. 1 over 5 plus 1 over 20. Okay, so I got n equals 3.75. So I need 3 3/4 workers. Well, remember, I need it done in 5 hours or less. So what that really means is n equals 4. My time will be less than 5 hours. That's what I want. But since I can't have a fraction of a worker, I'm just going to hire 4 extra guys, and we'll get the job done in under 5 hours. That's how this one works.